We all know of golf. Big franchises, big tournaments, big sponsors, Tiger Woods, and rich old people. One aspect that people don't realize is that golf has a lot to do with physics.
Hey guys, I'm Tyler Woods. I love golf. And physics. This is my journey to finding the best golf ball.
Yeah, I didn't really know where to start, so I tried looking into the past. My research has brought me all the way back to the 1800s, days of the first golfers. Originally, the golf ball came from the sap of the sapodilla tree, a plant native to Malaysia. These original balls were called gutties. They didn't travel very far. Eventually, etching/cutting textures, so raised textures, were introduced to the golf balls. These helped with consistent flight. The sap also became rubber, as it is able to capture more potential energy. The biggest revolution to the golf ball, however, is when people realized indentations allowed for more travel distance. Though they didn't know the physics and aerodynamics as to why this occurred at the time, this eventually led to the development of the iconic golf ball, the dimple.
Luckily, I do have some good friends in the Tireless Golf Company. They're gonna help me solve the riddle with dimples. Hey there, I'm Mr. Tireless. Welcome to, Tireless HQ. Come inside to our research facility.
We have to take care at every step that the process is in control.
And making sure that every golf ball that we provide is worthy of the Titleist brand.
Everyone has pride that over these generations we've been able to maintain this number one position and earn that number one position based on the precision of what we do and the quality of what we provide the golfer.
To be honest, there are a lot of factors that affect golf ball flight, Tyler Woods, but all dimples have proven to be a characteristic that meets all of these factors. Essentially though, the main goal is to reduce drag in all forms possible. This brings us to the concept of laminar versus turbulent flow. Laminar flow is when fluids travel on a straight, uniform path. Meanwhile, turbulent flow is when fluids are traveling in more chaotic pathways, oftentimes characterized by whirlpool movements. A smooth golf ball will render a laminar flow, while a dimpled golf ball will render a turbulent flow. Now, based on a lot of our background knowledge, smoother surfaces will result in less drag, correct? We see this in car and airplane designs all the time. However, in the case of a golf ball's shape, a laminar airflow will cause for a large separation point to appear behind the golf ball, which causes a difference in air pressure and ultimately results in a drag force in the opposite direction. Tubular airflows also cause this separation point, but the air in fact lingers on the surface of the ball for longer periods of time due to dimple irregularities. Therefore, the separation point is quite closer and smaller in comparison, and therefore result in less drag behind the ball. Additionally, golf ball dimples also aid in creating lift. Lift is a force that enacts on an object when the fluid it is traveling in is forced downwards. With a smooth golf ball, you have some amounts of lift, as it is traveling in a forward momentum. But with dimples, the increased friction on the ball allows it to have a lot of backspin, which almost doubles the amount of lift. Deeper dimples would create less drag in the ball's wake, while shallower dimples in comparison would allow for more lift. The best golf ball dimple design patterns have a balance of the two to maximize travel distance. Thanks, Mr. Tireless. Now I'm going to try to apply and use all the information that you have given me to make my own golf ball design. Even big golf ball companies do it with this process, and who knows, I might get lucky. My first concept is to change the shape of the dimple entirely. Almost all of golf ball companies use circular dimples to cover their balls. But since circles do not fit together completely perfectly, there is a surface area in between the circles that is smooth and results in more drag. My golf ball would have a dimple pattern made up of hexagons, since they fit geometrically together perfectly. Perhaps similar to that of a soccer ball, this will help to remove any smooth surface. This should create an even smaller wake trailing behind the ball, as well as generate good lift, as its flow will be completely tubular. Now, my second design concept is slightly more technical in nature. If you imagine this as a circular dimple of a golf ball, normal golf ball, then this will be the air resistance moving against it. The air would be reflected off of this surface, like so, causing for a lot of drag, as the angle in which the air is reaching the side of this dimple to be very severe. However, my proposition is to maintain this circular shape and overall dimple design. However, we divvy up the indentations in this dimple to become 3 ovals, like so. And this part will be completely raised and indented. Therefore, when the air reaches these dimples, they will reflect off at a much less severe angle, like so, in all directions, no matter the rotation or orientation of the ball. It's like so. Therefore, we are reducing the amount of surface drag as the
Angle at which
the air resistance is reaching these dimples is less severe. Additionally, while keeping the benefits to the wake of the golf ball, as these dimples still maintain their overall indentations and turbulence layer effect. Unfortunately, due to certain time constraints, I was only able to completely finish and print the hexagonal golf ball design. After a long design and printing process, I was finally able to make 2 golf balls, one of a 10% infill density and one of a 80% infill density. I'm here with my good friend Jun Young, a golf expert. He's gonna help me test these new golf balls today. First test of the hexagonal golf ball dimple. So that first test did not go as planned. That's okay though. It's hexagon dimple golf ball second test. This one's about 80% denser, more weight, more stability. Let's try it out. Junior. Dr. Jun Young Cha, I'd like to congratulate you today, helping us test out this new golf ball design. Let's head back to the lab. Unfortunately, that design was a failure. In the end, Jun Young's ball that he hit only flew 150 yards. In comparison, that is much less compared to the 300 yards that he was hitting with his normal golf balls. Of course, there are a lot of factors that could have affected this. For example, the golf ball's density and the golf ball's material is not nearly that of an actual golf ball, being made of rubber and other materials. However, all that we have learned throughout this process about wake, about drag, about the turbulence layers, and how all of these factors affect golf ball flight can hopefully inspire and help us create new golf ball designs in the future. Thank you.